So are we ready to make some contacts with this thing? I'm ready. Let's take it in the other room, hook it up to a well-matched antenna. I've got a simple pi-type tuner we're going to run it through. We're going to see if we can check into some of the nets that are on Saturday mornings and some of the casual guys that get on Saturday afternoons. They're all running mostly PDM rigs, and they should get a kick out of trying to pick this thing up with 10 watts. This is WU2D, Whiskey Uniform 2 Delta, on my little PDM rig that maiden voyage. This is a little QRP 10 watt job. I wonder if you can copy WU2D.
WU2D is K1SRE. Roger, copying you. I guess that's the rig that you were building there. I've been watching your episodes, and although I don't know if the mic is matched with the rig or what it is, you're a little bit muffled. It's not as clear as I would expect to hear with the rig you're building. But anyway, good morning.
Okay, I haven't got the muting quite done on this. K2SRE from WU2D. Yeah, I noticed that I'm getting some problems with the audio. I have to get in there and see if I'm overdriving the chip, the PWM chip. And nice to hear that first time I put the transmit switch on, somebody came back, that's for sure. But yeah, this is the little rig that I'm building, and this is the first time I've attempted to put it on the air. So we'll see how this develops, but it's encouraging so far. We'll just have to work out some of the distortion that I'm seeing. WU2D.
WU2D is K1SRE. Yeah. It sounds, it sounds like I don't know what you're doing about straight in and straight out, but it's like a little on the bassy side maybe, and a little presence. I think it's the presence there. I think it sounds fine. Over.
Okay, very good. Yeah, that may be because I've got so much cut filtering in. I was very concerned about the high frequencies on the audio. So I have a pretty severe filter in on the audio, and I can certainly adjust that to open it up a little bit. But yes, I did notice that as well, that it's a little bit bassy.
It sounds pretty good for a peanut whistle over.
Well, it is indeed a peanut whistle. I see no more than about 7 or 8 watts of carrier, and of course it peaks up to probably double that, you know, on the voice peaks. But I just wanted to experience PDM for the first time. This is the first time I've ever used a PDM rig, and nice to hear that the maiden voyage is working out. So I'll say 73s and go up and have a celebratory breakfast. WU2D on PDM. Good morning, W1VTP. This is WU2D, your neighbor, on the junk box PDM rig.
It sounds almost like if you don't have an equalizer, you need to have one. It sounds almost like you're amplifying the mids, or the muds rather, and the highs are definitely lacking. And I have been following your article, by the way.
So good morning, Steve. I just wanted to let you know that this is my maiden voyage on my junk box PDM rig, my cigar box PDM. Apparently I need more highs. I did a very severe job on the audio filtering, so I need to get some equalization in there according to Al. But you know, I want to see what's going on with it and see if there's any fribblies off at 60 kilohertz where my digital PWM is. See if I've got some big sidebands up there. But anyway, glad you guys are hearing this little 7 watt rig. It's putting out 7. Of course, it peaks up with the audio. I'll say 73s to the net. Mark, thanks for letting me in. WU2D.
Doing business on the weather, old man. This WA1H yell arm. By the way, I'm hearing that pitch weaker there, there, Mike. So, it's working, but as everybody says, you're kind of heavy on the 30 weight.
Yeah, I will get some equalization in on this and see if I can get some highs. This is an electret. It, you know, it goes to the moon, so it's obviously just my filtering on the front end.
It also seems like, you know, it's lacking modulation density. As well, I'm sure, with everything mixed up and feeding and controlled audio into the thing, it will probably be A-OK.
Yeah, Mike, I hear you fine. I can't, there's no way I'm going to be able to tell about your 60 kilohertz switching sidebands at this time. Maybe when the band quiets down, but yet we're hearing you. It's low power, but definitely doing the job. That's great. WA1QIX here.
Well, thanks, Steve. Yeah, this is my maiden voyage into PDM. I've only been avoiding it for 25 years, and you know, I made this thing as kind of a learning experience for everybody. So I've been doing videos on it for YouTube. 73s, everybody. WU2D throwing the little switch.
Okay, Mike, talk to you later.
So according to the on-air comments, my audio is low. I lack highs, which makes, of course, it very difficult to understand speech if you don't have any highs. And I'm rolling things off probably too abruptly in the audio range. So you might remember we have an op-amp that's driving the TL 494, and I have a pole of low-pass filtering wrapped around the feedback. So the first thing I'm going to do is I'm going to re-examine that value and lower it considerably and put that cutoff point higher in frequency and see if that brings up the high end and gives me more presence. As you know, there is an op-amp microphone preamplifier in this circuit, and I have a feedback resistor of 100K, and across that 100K I have a 220 picofarad capacitor. I'm trying to get a roll-off around 6 kilohertz. Well, in removing that capacitor, I got quite a surprise. Instead of a 220 puff, it turns out to be an 820 puff. So the thing was cutting in below 1 kilohertz, and by the time I got up to 3 kilohertz, 4 kilohertz, we didn't have a lot of audio left. It was down where I thought it would be around 10 kilohertz. So we had the wrong capacitor installed. While I'm at it, I'm going to be putting in a potentiometer to replace that fixed 100K. So I have a microphone gain adjustment. And you can see how I've carefully attached a shielded cable that has 2 wires inside. I have it set up so that it goes to higher resistance as you go clockwise, as a volume control should in a feedback circuit with an op-amp. And I've carefully prepared the ends so it won't short on the bottom. So I'll be able to adjust the capacitor at this point very easily compared to having to take the board out. And I will solder this into the bottom of the board to take the place of the 100K resistor. So some improvements. If I have to remove this thing, I might as well do an upgrade while I'm at it.
And are you currently, do you find that it's more fun working on projects than talking, or do you find that, you know, you can sort of do both? Anyway, it is interesting to see how you know, people change over the years also. I was constantly building, constantly. Oh, it's all right, I got this now, it's not big enough, it's not good enough. It's, you know, no matter what it was, I was always trying to improve. And, you know, not so much like that anymore in the equipment stuff, although I am. But it's changed to other areas. So it's kind of interesting how it changes. But so how are you in that respect? You know, if you get everything working, are you happy with it, or is that, well, all right, I'm bored now. I need to do something else. I got to fix this. I got to build something new. Where are you at? All right, so Mike is back, so I'm going to grab Mike there, WU2D, then we'll grab Mark in Groton, WA1QH2, Bruce up in Wisconsin, and Ted over in New Bedford. So WU2D, go ahead there, Mike.
Okay, very good, Steve, and thank you for letting me back in. You know, I discovered that I had a 820 picofarad cap across the feedback on the little op amp that I'm using as the microphone amp, and that certainly was restricting the high end. So I've at least been able to lower that to 150 puff, and we'll see if this helps the audio. I'm going to have to do some fine studying on the audio and see what's happening, but maybe I've got a little more high end now, Steve. Again, this is a homebrew junk box PDM rig, kind of a first principles PDM rig, although I am using the TL494 chip out of a ATX power supply for the modulator. And I first tested it with two bipolar transistors, bipolar modulator, bipolar class E stage, and it worked absolutely perfectly. And I switched it out to MOSFETs, and it also worked good with MOSFETs. So at least at this power level, the 10 watt out level, it seems to work with transistors no matter what kind of switches they are. They seem to work okay. Thanks for letting me in. WA1QIX, I am a tinkerer of all things, from WU2D.
Very good, WU2D, WA1QIX, and all yours. Not too strong. Not too strong up here, but I think you're still only running 7 watts or something like that, but I did get most of that. Well, it'll be interesting to hear how you make out with that transmitter. The audio still sounds a bit not enough presence rise, I guess is the way to describe it. Anyway, good to hear you, Mike. I'll be very curious to find out more about that over time, and we'll look for you next week here on The Lonely Guys. All right, WA1QH2, Mark, and then Bruce, and then Ted. Go ahead, Mark, WA1QH2.
WA1QIX and The Lonely Guys, WA1QHQ. First of all, Mike, I can hear you down in Groton, and you know, the signal is low, but, you know, Q5, no problem down here. And, you know, first and foremost, keep the shack running. And that's why the Lonely Guys comes in handy for me. Good way to exercise the transmitter on a regular basis, make sure everything's working. I do far more listening than operating. That's my fault. I need to change that. But I like to make sure that I have the main transmitter here running, the T3, and a backup, which would be the ART13, and then a backup to that, which is a Valiant. They all work.
WU2D, W1DIN, good evening.
Yeah, I didn't sign.
Well, you didn't reply.
Okay, good evening, guys. This is WU2D. My name is Mike, Mexico, India, Kilo Echo. And I'm just running a homebrew PDM rig, junk box rig, about 10 watts. U2D, again, the handle's Mike.
Okay, Mike, we missed a fair amount of that because of a tuner-upper.
This is a little junk box rig built in like a cigar box type enclosure. It uses a couple of IRF 630s. One is the PDM modulator, and it uses a TL494 out of a ATX power supply as the pulse width modulator. And then basically just crystal divided down, driving the Class E final for about 10 watts output. But still working on it, still trying to get things stabilized on it, but it's a cute little thing. It's all junk box and a lot of fun.
Hey, Mike, I got most of that. You could use a little more audio on your transmitter, and that's really excellent. You got the IRS 630s working for its supper and PDM as well as RF mode. So yeah, if you can get a little more audio on the carrier, that would be good. So, Marshall, did you hear much of that? W1HK, W1DIN. W1DAN. W1HK. No, I didn't. I didn't get a lot of that. It was down in the noise. WU2D, Mike, are you in?
Yes, I should be back. This is WU2D, hopefully with a little more modulation than I had before. And yeah, I'll get this thing settled down. Again, very low power, just using very simple. It's using a couple of flip-flops, driving a couple of bipolar transistors, and a TL494 out of an ATX power supply, driving a couple transistors, and right into the MOSFETs with a homebrew filter for the PDM. Nothing fancy. I'm only using 60 kilohertz for my switching frequency, so I thought I would start down there and then maybe go a little bit higher. But again, a lot of fun. It has an onboard power supply, onboard TR relay, mic amp, everything's built in. Simple electret microphone. 73s, guys. I'm going to get out of here too.
Very good, Mike. Excellent. And your audio did help. Good on the lineup of semiconductors driving. Very, very inventive. You should do a write-up on AM Phone on the Class E forum. And if you, do you have any negative clipper? If you have a negative clipper for audio, you can even give us some more audio if you'd like.
You know, it's funny because I'm so ignorant. I'm doing this like first principles, deliberately not looking at anything, and just doing it, you know, from scratch, so to speak, is solving each problem one at a time. So the solutions I've come up with might not be the right solutions, that's for sure. But yeah, you're right. I'm using a UF 4004 ultra-fast rectifier for the damper diode. That, again, that comes right out of an ATX power supply. And then there is no negative peak clipping, you know, that you can't really put that on this. There's no iron or anything in here, but some type of pre-processing. I'm sure you guys have been doing that for 25 years.
Okay, very good. Yeah. I think you're almost there as far as modulation level. I just didn't know if you could get to the point where you're doing some carrier cutoff on peaks.
Yeah, again, I'll get the thing straightened out, but it's just good to see it running. Again, about 10 watts out. This thing will do about 25 watts out with the 630s, and I cut it down to around the 40% level and let the PDM fill it in. So about 40% of the voltage is on the final. That's the way I'm setting it up. I don't know enough to know where I'm supposed to set the PDM. I'm just very happy it's working at all. Over.
Okay, very good, Mike. Yeah, you set the PDM to about, you know, with no audio, about 40% duty cycle. And then with modulation, obviously that'll vary. And okay on your PDM filter starting early. It might be starting early. Yeah, I in your audio stage, I put a negative diode clipper, low-level negative diode clipper. You can also try and do it at high level, and then you can get some more audio on your carrier. It's a good carrier. You're up to 20/9 in Natick, which is excellent for your power level. And the audio's not bad. It just needs a little bit more to get through the noise floor of 75 meters. So looking at your QRZ photos, we may have met in person at Nearfest. I like your mobile setup, the ARC-V mobile setup. So good job on getting the PDM going, and yeah, I set the duty cycle for about 40%, and then you can get a little bit of positive modulation on that. So WU2D, W1DAN. 3CX.
Thanks for letting us monopolize a little bit here, guys. And this is all good information for me. 73s, guys, it was really nice to be able to break in. I'm using a divider off a 31 megahertz TCXO, And that puts me right on this frequency. So you can figure out how much I'm dividing by with my flip-flops. 73s, guys.
That's a lot of division, geez. Excellent. Okay. We'll talk again, Mike. Thank you so much. And congratulations on getting the rig going. N3 CXT WMDA.
So let's take another look at the schematic. And remember, I built this thing in one box. Everything was bunched together with not a lot of ground plane. And there were some warts and ugly things that did occur with the transmitter. But let's go over some of the things that I found. First of all, you notice I have cut the line going to the 5 volts. Basically, I had a little problem when I hooked this up to a receiver. Having this running over here, the frequency was sneaking into the receiver. So we have to actually switch the 5-volt power going to the flip-flop. So this is not the be-all and end-all PDM rig. Remember, this was an experiment. This was a learning experience for us. And I stuffed everything into one box using junk box parts and commonly available parts. Now, I might have done things a little differently, but I used that simple schematic that we've been looking at over and over again, and I tried to build on that and tried to remain faithful to that original design. Now, I took license here in that I used a flip-flop divider. In one case, I used 2 flip-flop dual packages to divide down 31 megahertz, and in the other case I used a single flip-flop package with a ×2 crystal. This seemed to work. It drove the BS-170s, and I could drive the bipolar Class E very nicely. I'm not as happy with this system driving the IRF 630, and I think you would need to play with the ratio on this transformer to get it to properly drive this MOSFET. So I was never totally satisfied with this system, and I did not optimize it like I did with the bipolar. We had to change capacitors on the output. Turned out our capacitors were overheating. So quite a bit was learned up here in the Class E chain. Down here we use the TL494. And I found that I was getting some drift with the 494. We have to be very careful to use a very, very stable capacitor here at C30 because this is a free-running oscillator. It might be worth looking at external control for this oscillator to get a little more stability. The op-amp drive off the microphone seemed to work okay, but I made a rookie error and installed an 820 instead of a 220 puff here, and the audio sounded very muffled in the presence, or the highs in the human voice did not come through well. Most people do run some type of modified audio into these pulse duration modulators because they're so flat. People oftentimes use optimod equalizers, negative peak limiting type systems, and that's usually all done up front in the audio chain. Rarer is to find that type of peak limiting over here in the RF chain, like we do with typical tube negative cycle loading. This driver circuit seemed to work very well here off the 494, and maybe this is what was needed up top as well. So it's well worth trying a complementary symmetry driver in place of the two 170s. But again, I think if we just change the ratio on this transformer, we can get better drive into Q3 and stabilize things. I am not entirely satisfied that the filter circuit is proper at all. It does work, but it certainly doesn't seem to make sense when you consider the impedances involved. I think that the 7 millihenries is way oversized. Something half that I think would be a little more appropriate. So again, a good first principles PDM attempt. Do I consider it to be a successful project? I'm going to give it a C, maybe a low B. It's certainly not a home run, but
it is able to make contacts at the 10 watt output level, and we do get nice upward modulation with it. But hey guys, you got to build this stuff on ground plane. Using a good ground plane will give you much better results than what I got stuffing everything on one little piece of perf board.
So the first thing you guys are going to ask me is, do you consider this project to have been successful? I don't think so. I think I bit off a lot more than I can chew with this project. Yes, it works, it makes contacts, it actually is a pretty complete schematic. Each piece was developed fairly independently, but were things optimized to the point where they actually were working to the best of their ability? Was I getting the most efficiency out of the MOSFET, for instance? Putting everything on this one little board kind of turned out to be a disaster. It's very difficult to rework and optimize circuits once you got it on this impossibly tight board using this perf board type construction. So it needs to be deconstructed into small bite-sized chunks, and you really need ground plane. One thing I've learned with this system is when you're doing analog and when you're doing RF circuits like Class C or Class A amplifiers, regular audio amplifiers, everything acts pretty well using ordinary devices like regular disc capacitors and so on. Garden variety parts work very well with linear and simple RF circuits. Tube circuits, very, very forgiving. But when it comes to this Class E stuff, the Class D stuff, when it comes to pulse duration modulation where you have digital signals, those parts become very important. And you actually cannot get the performance out of those ordinary junk box parts that you're used to using. So that's why I say this project was not really entirely successful. There's a lot more work that needs to be done to tame this circuit. Did it prove principle? Did I learn a lot? Yeah, I'd never even made a Class E amplifier before. I'd never done pulse duration modulation before. A lot was learned along the way, a lot of fun, and we made some contacts on the air. But do I consider this a reference design or something that people would reproduce? I'm sorry, it just does not pass muster.